are you students? Welcome back with new lesson, Physics Grade 10. Last lesson we have studied atoms, and we have studied a model of atoms, and we have studied different models of atom, start Rutherford, Bohr, and so on. Now we will make fast revision about atoms and continue with new lesson to speak about radioactivity. Radioactivity and particles. Radioactivity describes the structure of atom in terms of protons, neutrons, and electrons. These are particles that make the atom, and use a symbol such as C. We know that this is the symbol of element, and this is a mass number, and this is atomic number. To describe particular nuclei, understand the terms atomic, proton number, mass number or nucleon number, and isotopes, and we take also isotops. Understand that alpha and beta particles and gamma rays are ionizing radiations emitted from unstable nuclei in random process. Describes the natures of alpha and beta particles and gamma rays, and recall that they may be distinguished in terms of penetrating powers. Describe the effects on the atomic and mass numbers of nucleus of the emission of each of the three main types of radiation. Understand how to complete balanced nuclear equation. Atomic structure. Fast revision about atomic structures. We study that an atom consists of a small central nucleus composed of protons and neutrons surrounded by electrons. This is a nucleus concentrated or contained protons and neutrons. Protons, we know that it's positive charge, and neutron is neutral charge, and electron is negative charge. Number of protons equal number of electron, and called atomic number. Mass number is the number of neutrons added to number of protons. Atomic and mass number. The atomic number or protons numbers of an atom is equal to the number of protons in its nucleus. The mass numbers or nucleon number of an atom is equal to the numbers of protons plus number of neutrons. These atoms as examples: protons equal 3, neutrons equal 4, electrons equal 3. So the atomic number equal 3 and mass number equal 7. Properties of protons, neutrons, and electrons. This is the particles, protons, found inside or its position inside the nucleus. Relative mass equal 1 unit. Relative electric charge positive 1. Neutron, it will inside nucleus. Relative mass 1. Relative electric charge 0. Electron outside the nucleus, its relative mass negligible and relative charge equal -1. Nuclear rotation. Nuclear rotation. An isotope of a carbon consists of 6 protons and 8 neutrons. This can be written as carbon 14. Carbon 14, it means number of protons plus number of neutrons, mass numbers equal 14. Number of protons equal 6, so number of neutrons, yes, equal mass number minus number of protons. Isotopes. The atoms of an element always have the same number of protons. Isotopes are atoms of the same element with different numbers of neutrons. It means the change will be in mass number, but atomic number is the same. 3 isotopes of hydrogen. We studied this example before. Hydrogen 1 equal 1 proton, 1 neutrons. Mass number equal 1. Atomic number equal 1. In this atomic number equal, yes, 1, but mass number equal 2. Mass number equal 3 but atomic number equal 1. The atomic number is the same at the 3 isotopes but mass number is different. This hydrogen 1, hydrogen 2, hydrogen 3, we call it deuterium and tritium. The start of new lesson. Ionization occurs when an atom loses or gains one or more electrons. When an atom loses electrons, it becomes a positive ion. So if we have a hydrogen as example, have one proton and one electron. If the hydrogen lost one electron, it will be positive ion. As example, lithium atom and charged, it means number of electron equal number of protons, so we have a balanced charge, but the cumulative charge equals 0, 3 negative and 3 positive. But in lithium ion positively charged because it lost one electron, it means the positive charge will be greater than negative charge by 1. Radioactivity and ionizing radiation. The nuclei of some isotopes are unstable, and when they decay, they give a radiation that causes ionization. This phenomena is called a radioactivity, and the radiation produces is called ionizing radiation. It means the decay different than ionizing decay. It means the nucleus of the atom will decay. It means we will have another element. We will have a different element because the proton number and mass proton number or atomic number or mass number will be different. So the nuclei of some isotopes are unstable, like uranium, like cobalt, and when they decay, it means will change its atomic numbers. They give off radiations that causes ionization. It means ionization, it changes this decay in nucleus will change the number of electrons around the nucleus. This phenomena is called radioactivity, and the radiation produced is called ionizing radiations. Not all elements have radioactivity phenomena, but especially for special element. When the atom decay, we will have 3 type of particles: alpha, beta, and gamma radiation. This is an alpha particle consists of 2 protons and 2 neutrons. It's strongly ionizing. It means this alpha particle is very heavy. It means it consists of 2 protons and 2 neutrons. So what's its charge? Its charge is, yes, it's positive charge. A beta particle is a high speed electron. It's produced when a neutron has decays into an electrons and protons. It's moderately ionizing. It's moderately ionizing. It means the protons, neutrons, we call it before that neutrons didn't have a charge, but after that we know or we have discovered when the the neutron decay, I will have protons and electrons, positive charge and negative charge, so this make the neutron has no charge. This decay, I will have beta charge and it less mass than alpha particles. Gamma ray are very high frequency electromagnetic waves. This is a wave, not a particle, but we studied before that any particles have a dual natures. Dual nature means particle natures and wave nature. The penetrating the powers of alpha, beta, and gamma ray radiation. At first, alpha particles is very heavy, so its penetration will be less than beta particles, which is heavier than gamma ray. So the gamma ray is high penetration power. This is a sheet of few centimeters of air spots alpha particles. We will see that particle of beta has penetrated and gamma ray has penetrated, but alpha particles didn't penetrate the sheet. Deflection by magnetic field. If we have strong magnetic field or magnetic field south poles placed behind the ray like this, we will see alpha particles will deflect it up and gamma ray didn't deflect, and beta turn back. Why? Because alpha particle is positive, so it will be attracted to negative electrode, and gamma ray is a wave, so it didn't have any charge, so will pass without any change in its direction. But beta ray is negative, so will deflect back. Alpha and beta particles are deflected in opposite directions due to their opposite charge. Is negative charge and positive charge. But gamma ray didn't have any charge, so didn't change its direction. Deflection by electric field. If we have electric field, alpha and beta particles are deflected in opposite direction due to their opposite charges. So alpha particle go negative charge and beta go to positive charge, but gamma ray didn't change its direction because its radiation didn't have any charge. Alpha decay. What happened? This is example about alpha decay. Uranium 238, this is mass number, and 92 atomic number of proton 92. If we want to calculate the number of neutron, we will subtract this number from 92. After it decay, it will be thorium with atomic number 234 and 90 atomic number plus alpha particle. If we added 2 with 90, I will have 92, and 4 with 234, I will have 238. This is decay alpha particles. Uranium 238 decays to thorium 234 plus an alpha particle. We must note that the mass and atomic numbers must balance on each side of the equations. 238 equal 234 plus 4, and 292 equal 90 plus 2. The alpha particles can also be noted as beta decay. Beta particles consist of high-speed electrons. They are emitted by isotopes that have too many neutrons. As example, C614, it will be decayed to nitrogen with decaying beta particles -1. Carbon 14 decays to nitrogen 14 plus a beta particle. The beta particles being negatively charged has an effective atomic number of -1. The beta particles can also be noted as beta -1, 0, and its charge equal -1. Gamma ray. Gamma ray or gamma decay is the emission of electromagnetic radiations from an unstable nucleus. Gamma radiations often occur after a nucleus has emitted an alpha or beta particles. Example, cobalt-16, it will be changed to 2760 here. This is the same element, and we have gamma ray. No change here, but we have radiation because gamma ray electromagnetic wave, not a particles like gamma ray is like beta and alpha particles. Changing elements. Both alpha and beta decay causes an isotope to change atomic numbers, and therefore element alpha decay also causes a change in mass number and atomic number, and also change the element, but gamma ray didn't change the element. just we have radiation or radioactivity element like cobalt, which we use it to treat in medical to treat the cancer. Decay type alpha, beta, gamma, atomic number down by 2, it make down by 2, and mass number down by 4, because we have 2 protons and 2 neutrons. 2 protons from atomic number and 2 protons plus 2 neutrons equal 4 from mass number. Beta up by 1, no change. Up by 1, it means it will change. We have extra 1 protons, so it will be up by 1, but no change. Why? Because protons, number of neutrons, change to 1 protons and electrons, so we have lost 1 neutron and added 1 proton, so we will not have change in mass number, but we have change in atomic number, so we have a new element. Gamma ray, no change in atomic number or mass number. Complete the decay equations below. This is the example. If we have this, it must be -1, so -1 from 26, it will be, yes, it will be, yes, 27, because 27 minus 1 equal 26. The number of protons behind the arrows, it must be the number of protons front of the arrows, or before decay and after decay. So will you have a change in atomic number, so we will have a new element. Also this number, it will be still the same because we have 0 atomic mass number. Also here we have beta alpha particles, we have 4 atomic number, so we have 2, so 2 plus 86, it must equal 88, and the number of mass number, will it change or not? Yes, equal 224 minus 4, it must be equal to 220, and so on, like this. Thank you, goodbye, and goodbye with new lesson.